Hi everyone, so today I'm just going to give a quick little proof that I found quite compelling for a number of reasons, and I hope you do too. So I'm going to tackle it in a couple different ways. First I'm going to start with one that might be not nearly as approachable as for many other people, and then slowly kind of work my way towards a little bit more of a simplistic sort of idea. So as you can see here, we have this statement being made, this proposition, 1 equals 0.99999 repeating as it just goes on ad infinitum. So how can we prove that? I mean, clearly it seems a little bit absurd. They have no, I mean, they don't, they're, one's closer to the other. There's not much of a, relationship immediately that catches the eye here that you might think. So let me go about establishing that then. So here we go. So basically what we want to do is take our 0.9 repeating decimal here and formalize it a little bit. So how can we do that? So what we need to do is find a common ratio of every succeeding factor. So let's start out by just writing them out one by one. So starting with our first term, we're going to have 9 over 10, right? That's the first one, plus 9 over 100, plus now the third, 9 over 1000, and then this one here, we got 9 over 10,000, and that's just going to keep going, right? Alright, so to get our common ratio, the next step we should take is to pull out our common ratio. So let's just factor out 9 over 10 here. So let's factor this out, 9 over 10, and we're going to get 1 plus 1 over 10 plus 1 over 10 squared plus 1 over 10 cubed plus dot 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 dot. And that's going to keep going, right? Alright, so it seems that we've sort of established a common ratio at this point. Now we have our constant, which we're going to incorporate into our series, but our 1 over 10 is the key factor here that we need for our common ratio. So basically, to generalize this statement, I'm going to erase some of this so I can clear some room here. So to generalize this statement, what we need to do is write out our geometric series formula. So at this point, we're going to have sigma as it goes on to infinity at n is equal to 0, and then our constant value, otherwise known as our a constant, so that'll be 9 over 10, and then what we have here is our general term 1 over 10 raised to the n, because every nth term you're going to end up with this subsequent result. So perfect, we have our geometric formula now. So now all we really need to do is apply a general formula for the geometric series, which I'm not going to prove here, but you're just going to have to take my word for it, that it applies to an infinite sum of components here, and just believe me, maybe I'll prove it in another video. So basically all we need to do at this point is write out that formula. So here's what we know. The formula is written as such. So it's basically our constant a, which is this, divided by 1 minus our common ratio here. So 1 minus r. So basically all we need to do is just plug in those values here and solve for that. So let's do that. So I'm going to write 9 over 10 divided by 1 minus 1 over 10, right? Okay. Well, 1 minus 1/10 is just 9 over 10, right? So 9 over 10, and that's divided by 9 over 10. So let's take the reciprocal here, and then we're basically just left with 9 over 10 times 10 over 9. And as you can see here, you can cancel these values, and you are left with 1. And that is a pretty definitive proof there, right? So if maybe that doesn't leave you satisfied enough to just feel that that's a proper proof here, I will show you a little bit of a different method. Next one here, we're just going to basically set up the same formula. So 1 equals 0.999, right? Dot, dot, dot. Okay, so basically what we want to do is set this value equal to x. So let's do x is equal to 0.999 dot, dot, dot. Now, what we want to do is multiply x by 10 and this term by 10. So we're going to get 10x equal to, well, you multiply this by 10, you're just going to get 9.999 dot, dot, dot. Okay, so now what we want to do is subtract from 10 here, subtract x here, right? Subtracting x is going to give us 9x, obviously, but when we subtract x, as we established at this point, x is equal to 0.999, so it's going to remove all of the terms beyond the decimal. So we're going to be left with 9x is equal to 9, and then divide by 9, thereby x is equal to 1. Okay, there's another one. That one's not bad. All right, well let's try one more here. So this one's probably most people are pretty comfortable with this idea here. So we have 1/3, right? 1/3 is equal to 0.333 repeating. So 0.333 dot 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 dot. Okay, so let's multiply by 3. Just multiply the whole statement by 3 here. So multiply this all by 3. And what we're going to be left with is 3 times 1/3 is just 1. So I'm going to get 1 is equal to, well, how about that? You multiply 3 by 0.3 repeating, and you get 0.9999. And that's it. There's an interesting little proof there. I hope you enjoyed that.